I'm going to be making a Swift Playgrounds game using my iPad, built with SpriteKit and a little bit of SwiftUI. It's going to have physics element to it. So I get to experiment with a little bit of SK physics, which is something I have played around with, but not really to this extent before. I think it's going to be a fun build. We'll see where it goes. Let's jump into Swift Playgrounds and get started. We're going to open up an app, and it's going to give you this placeholder. So I'm going to rename this Rockets Are Fun, and we'll jump in. I'm going to, again, name my app, Rockets Are Fun, and we'll pick a different placeholder icon for now. I like this arrow because it kind of looks like a rocket. Now, if you were to publish this to the App Store, which you can do, if you're enrolled in the developer program, you can do that from Swift Playgrounds. You do need to have your own custom app icon. All right, so right off the bat, you have a content view and my app, which contains a window group of that content view. That's what the user will see when they launch the app. And you can see that here. Right now, it's just a system name of globe, which is an SF symbol, and hello world. What we're gonna do is we're gonna build out a little bit of the user interface. We'll start very simply, and then we'll work our way to more complex as we go. I'm gonna start with a text view of just Rockets Are Fun, basically just our title for now. And then I'm going to need a sprite view. Now, this is something I need to create. The first part of it is that the content view is going to need SpriteKit to be imported, but we're also going to need to create that scene. That is going to be a new file, and we're going to call this GameScene. So just to get this off the ground, we're going to import SpriteKit here, and then we're going to have a class called GameScene, and it's going to be of type SKScene. And then just to show that I have something here, I'll create a variable. We'll just call it node for now, an SKSpriteNode. And then we're gonna have our didMoveToView. And when we get to this view, we'll do node equals SKSpriteNode, and we'll have it be of a color we'll call cyan, and we'll do a CG size of width 50, height 50. We'll just add it to the scene. So add child node. All right, so that's our game scene in a nutshell right now. Very basic. So then we'll come back to content view. Now, inside of content view, we're actually going to, inside of our content view struct, we're gonna create a game scene, which is of type SKScene, and this is going to let our variable here, GameScene, we're going to let GameScene equal GameScene, and this is just going to be our file that we just created, right? The class we just created, and then we'll give it some properties. We'll give it a size, CG size, width 600 by 600, nice square size. Scale mode, we'll do aspect fit, and then background color dot clear, and we'll change the coordinate system of our scene to be have an anchor point of 0, 0. And then we're going to return GameScene. So then inside of our sprite view, we're just going to call our scene. So scene, GameScene. And we'll give it scale to fit, ignore safe areas, and we'll give it a little bit of padding just to make it set out. And now when we come over here, we should see our game scene with our cyan colored cube, and Rockets Are Fun. Not much of a game yet. So let's add a bit of functionality. I think what we're gonna wanna do is we're gonna wanna get this placeholder of a rocket. We're gonna wanna get it moving through physics by using impulses. And I came up with an interesting input system for this. So let's implement that now. So that's going to be back in our game scene, which is going to contain most of the logic for this. So let's change our node from node to rocket. And just to make it a little bit cleaner of code, I'm going to pull out the size here. So 50/50, and then I'm just going to change this part of the SpriteKit node to rocket size. So everything's basically still the same. But now, we need to basically make this a game. So I'm going to give our rocket a bit of physics. First, we'll need to give it a position. I'm going to have it be CG point. And we'll do X, 300, 100. So that should put it about the middle of the screen. And then we're going to give it a name. And it's rocket.position. Name. And this is going to just be rocket. Just so that we can reference it later if we need to by name. And then we'll give it a physics body. Now, to do this, we're going to need to turn on the physics of the world here, rocket. So we're going to give it a physics body of rocket size. Now, physics exists in the world. We have gravity and everything, but we want to control it, and we're going to want to have contact. So we need a physics, SK physics contact delegate that's going to allow us to, pick up the contacts, and we're going to want to, maybe control the world a bit. So we're going to have physics.contactDelegate equals self, and we'll also control our gravity. So you can have, gravity is by defaulted to a basic level. I decided for this game to just reduce it a little bit here. So 0.9. So now things fall a little bit slower. It's not as dramatic. But we don't want our rocket to fall off the screen. So we need to create a kind of a ground level here. So let's create that now. We'll do another variable. We'll call it ground level. And this will be an SK sprite node. And var ground level, var ground level size. For this, I just went with a quick and dirty approach here to make sure that we had a large enough size that, reasonably the game wouldn't, you couldn't get to the end of it in the time that the game had, because we don't want people to fall off the end of the world. The concept of the game will prohibit the ability to get to the end of the world, even if you were to try. That's the idea. And we may change this down the road anyway. Again, this is going to be ground level. We'll do an SK sprite node with a color of .brown and ground level size. And then we will do ground level dot position equals CG point, and this will be 300 by 10. And we'll do add child ground level. We don't have physics for our ground level yet, so we need to make sure we give it some physics. Ground level dot name equals ground level. And ground level dot physics body equals SK physics body of rectangle dot ground level size. So now, don't forget this part. Your physics body for ground level is defaulted to is dynamic. We need to set this to false. And now our physics body won't fall with our rocket ship, and it will capture it. So now we have a rocket ship that is sitting on the ground, but we can't do anything. We can't move our rocket. So this is where I came up with a solution for controlling the rocket ship in an interesting way. At least I think it's interesting, but I'm kind of a novice, so you might have a better idea. Anyway, let's take a look at what I did. For controlling the rocket, we have basically the player is going to touch the screen, and they're either going to choose to rotate the rocket left or right, or thrust the rocket in the direction of its rotation. To do that, we're asking the player to tap on the screen at specific zones of the screen. So we're going to override our touches began, and we're going to, get our first touch so that we know that we have the first one, else we'll return. And then inside here, we're going to say touch location, which is a variable we need to create, is touch.location in self. So let's create our touch location, which is just var touch location CG point. So that's all that is. So now we have our touch location, and we can pass this into a function that we will create called fire thrusters. And we're gonna pass our location as touch location. So now let's create this function. This is a function, fire thrusters, and then this is going to be a CG point. And so now when we come in here, we are going to have the location of that touch, and we can do stuff with it. The way that I set this up was if location.x is greater than 100 plus the rocket.position. So we get our rocket position and add 100 to it. So the right side of the rocket, and it's rocket position.x. Because we don't care about the y value. We just want the x value of where the player touched. If they are touching 100 pixels to the right of the rocket, then we want to rotate the rocket to the right. So we're going to say rocket.physicsBody.angular impulse, apply angular impulse of a new variable called rocket thrust angular impulse. And we will copy this, and we're going to create this up here. Let's put it with the rockets stuff, var. And this is, so this is set at 0.005. So just a small amount of angular impulse. Angular impulse is going to be applied negatively for moving to the right. And then we're going to have if location, or I guess it's else if location.x is less than 100, less than negative 100 plus the rocket.position.x. So the other way from the rocket position, then we're going to say rocket.physicsBody.angular impulse, and we're just going to apply the positive of that. All right, so now if you're in between that, we're going to have what happens. We need to get up at the top here, when we come into our fire thruster, we're going to get a, we're going to adjust the rotation before the last, or basically get the rotation of the current position of the rocket. So we're going to say, let adjusted rotation equal rocket.z position plus cg float.pi divided by 2. And this is in like this. And then we are going to have two new variables up here for the rocket. We need a variable called rocket x thrust, and that will be 115. It's a CG float, I think, 115, and a var of rocket y thrust, and that is going to be a CG float of 40. All right, so inside here we're going to let dx equal rocket x thrust times the cosine of our adjusted rotation. And then we're going to let dy equal rocket y thrust times the sine of our adjusted rotation. So now, when we come down to else, when we want to move our object forward, we are just going to apply that impulse to the physics body as an impulse here of impulse of a CG vector dx of dx and a dy of dy. So now when I tap the screen, I can rotate, but it's admittedly rough right now. We need to fix this. So the next thing we need to do is make sure that the camera stays focused on our rocket. That's as easy. That's pretty simple. We're just going to create a new camera node here called var rocket camera, and that's going to be a sk camera node. So, and then inside of did move, we're going to say self.camera equals rocket camera. And you'll notice that the position is all weird now. That's because we need to update our camera's position inside of our update function, which we need to create. So we're going to do update, and we're going to say rocket camera dot position equals rocket dot position. So now wherever the rocket goes, the camera will follow. But it's really hard to control. To fix that, I added a few cool little things here. I created a projectile that comes out the back of the rocket as you move, and it's color-coded to which action you have taken. This helps the player see exactly what they're doing. So inside of our fire thrusters, we have a new particle. We're going to let our thruster particle equal an sk SpriteNode with a color of, for the right rotation, we're going to have it be orange, and we'll do a CG size of width 5 by 5. We'll do position equals location, or I'm sorry, position equals rocket dot location or dot position, and then we'll add the child of thruster particle. And then we can just copy this into each one of these. And we're going to just change the color. So we'll do dot red for the left turn and dot blue for the thrust. So now when I go, you can see we have our rotation left, up. It's still a little bit weird. One of the things we need to do is we need to give our rocket some mass. Rocket dot mass, physics body dot mass equals 1. And we're also going to give it some physics body angular dampening, which will resist the rotation as we rotate. This makes it a little easier for the player to control what's happening. So now you can see since we have the mass and the angular dampening, it takes a lot more taps to do anything. But I'm noticing that right now our rocket is not moving left or right. Typo, so this is the rotation. So now if I do this, I can go left to right, I can go up, and basically control it. It's still not perfect because you don't really know where you're touching. So what I came up with next was to kind of use, if you've ever opened up a game template file in SpriteKit, Apple has a demo with a spinnyNode. So I used that as a way to tell the player where they just tapped. We need to get a new variable called spinnyNode. And that's going to be an sk shape node. We're going to make it optional. Now inside of our did move to view, we're going to create a few things here. We're going to say let w equals self.size.width plus self.size.height times 0.05. And then self.spinnyNode equals skShapeNode with a dot init rect of CG size, and this is a width of W, height of W, and a corner radius of W times 0.3. This is copied straight from Apple's template. And then we're going to say if let spinnyNode equals self.spinnyNode, spinnyNode dot line width equals 2.5. And then we're going to say spinnyNode dot run. We're going to run an SK action on this dot repeat forever. SK action dot rotate by angle of CG float double dot pi, and it's a duration of 1. And we're going to have spinnyNode dot run SK action dot sequence, and inside our sequence we're going to have SK action dot wait for duration 0.5. SK action dot fade out with duration 0.5, and SK action dot remove from parent. So that's the setup there. And then inside of our fire thruster, we're going to, after we create our particle, we're going to say if let n equals self.spinnyNode dot as an optional dot copy as skShapeNode optional, n dot position equals our tap location, n dot stroke color equals sk color dot orange for this one, and we're going to do self dot add child n, and then these and this one's actually red. And then these get copied to the various things. So up here we will add this one, we'll change it to orange, and this one we'll add and we'll change it to blue. So now as the player plays the game, once this loads, I have an error. I missed, this is dot init here. Oh, rect of, there we go. All right, ready for this? So now when we tap, we get our blue for here. And then when we want to rotate to the right, we get an orange one. I need to fix the controls here. Something is definitely way wrong. Oh, wait a second. You know what I did? Unless they're backwards up here. That's, yep, that's what I did. This is 40. This is 115. Okay, now we should be a little bit better. Yeah, so now we can rotate and we can move, and we get you know, cool little animations when we do that. I'm going to pause here for now. I'll be back later with more. See ya.